Actually? How does it look like? Yes, I didn't know how to draw it.
Okay, come get your exams if you just walked in, please. So I'll have to carry them around. Here, I'll give you today's anecdote first while we wait for the people to show up.
Oh yeah, that's still on.
Okay, we're starting. That means you're stopping. Number 1, what character is used to terminate character array string? C, \0. Number 2, which of the following can be used to terminate a loop?
C, great.
C, great. Number 3, what is the output of the following code, assuming all elements are declared? You can read it in x equals 0, while x less than 100, so forth. It is B. You think? Does that mean you got it wrong?
Yes, sir.
Uh-oh. Was it the less than 100, where you took it as less than or equal to 100?
No, I don't know what I was thinking, honestly.
Okay. Now you have something to study. Left side. First person. Number 4. Which of the following looping constructs always has a semicolon at the end of the loop? E. None of the above? Nope. Do while loop. C. Do while loop is the only one that has a semicolon at the end. Number 5, and last of that row, last of the side row. Which of the following denote components of a for loop? All of the above. Initialization, condition, and increment or decrement. It's number 6. Which of the following is used for going to the next iteration of a loop? D, continue. Number 7. The do while loop behaves identically to the while loop. True or false?
False.
False. What is the difference? What's the difference between a while loop and a do while loop? That was almost a gimme. Why would they have 2 loops that behave identically? Next, how are they different?
The do while loop always executes at least once.
That's correct. Do while loop always executes at least once. Next, number 8. All loop constructs will execute their body at least one time. Being false?
Yeah.
Why is that false?
While loop checks.
That's correct. It always checks the condition at the beginning of the loop. And if the condition is false when you first enter the loop, it will not execute the loop. Next, number 9.
E.
Hang on, let me read the question. Number 9. What is the output for the following code fragment?
B.
B. Why? That's a hard question.
Let me look at it first.
Identify the particular. Okay. On some conditions, we're executing the continue. What are those conditions said in a little more plain English rather than code?
So when x is equal to 0 or x is modulo 3 equals 0, then it will continue and skip to the next iteration of the loop.
What does x modulo, that's correct. What does x modulo 3 mean?
For every odd number, or I mean, well, it's
Modulo 3.
divisible by 3, and it what's it called again? Well, the remainder will equal 0.
The remainder, that's what the modulo function is give me the remainder after a division. So, if anything, so what numbers, for instance, would take with modulo 3 would return a 0?
So odd numbers like 3 or 6 and 9, but 9's already skipped
And 6 is
it
not,
breaks at 8.
6 is not an odd number.
Or, sorry, divisible by 3. Sorry.
Divisible
Yeah.
evenly by 3 with no remainder. So that's the first part.
Yes.
Also, what's the other condition?
If x equals 8, it will break. It will stop. The
And
loop
what's
there.
the other condition in the if statement that I cut you off?
Oh, x equals 5.
So x is equal to 5. So you always print at least once while you're in the loop. Then you do not print twice if x is equal to 5, if the remainder of x divided by 3 is 0, in which case you continue, you do not get to the next print statement. And if you do get to the next print statement, and x is equal to 8, you break and exit the loop. The reason we go over exams is because, one, to enhance your knowledge. That's the biggest reason I teach the class. But two, you will see it again. You will see questions like this again. Number 10. Debug. Use the following code fragment. No assumptions. To answer the questions 10 and 11. Line A needs to be C. You need to declare X before you use it. Everything in C, all C type languages, but C in particular, has to be declared before you use it. Next, line D needs to be what statement such that we print only even numbers? B, X divided by 2. That gives you the result of X divided by 2. If you get to 4, what's X divided by 2 equal to? What's 4 divided by 2? 2, which is not equal to 0, which does not do what you want it to do. Next, same question. C, you seem to hesitate. Why? Not why are you hesitant, why is C the correct answer? And the modulus operator does what? It returns the remainder after dividing by that number. Number 12, using the for structure, which expression is evaluated first? A, which is what? Part of the for structure. It is the initialization. That is correct. You could have looked back to question 5 to see what that name is, but you didn't need another name for that question. Number 13. How many elements are in this array? Char word sub 20. It is D. But while we're on the subject and why you might have thought it was 19 incorrectly, what is the first index of that array? What is the last index of that array? 19. That's probably why you put 19. Sir?
How would you have phrased that question if the answer was supposed to be 0? Like, because you've only declared the array, you haven't initialized any of the variables within the array, is that correct?
How many elements are in the array? It doesn't say anything about what's in the elements.
Okay.
If the elements are still there and available for use. Second row, first person, the data type of each element in an array is D, the same. They are not all integers, characters, or floats. The only correct answer could have been the same. Number 15, what is the correct placeholder for working with C strings? E, %S. 16, next, 16. What is the correct placeholder to populate all the elements of an integer array in a single scanf call? E, not supported. Cannot do that. 17. The memory address of an array is the same as A. The memory address is the first element of the array. 18. True, false. A do-while conditional, a do-while with condition A as its argument loop can depending on value of condition A, execute more times than a while condition A loop.
True.
Yes. It is true. The do-while loop, as someone earlier pointed out, is guaranteed to execute once because it doesn't test the condition until the end of the loop. The while do loop evaluates the condition first, and if the condition is false, it will not execute the loop at all. Number 19. All the elements in an array are. That is correct. C. As sequential, incremented by type size, memory addresses. 20. When writing elements to an array, which loop can be used? All loops can be used. D. All of the above. Any knowledge questions, i.e. not about your specific exam, but in general, about 1 through 20? Describe one everyday aspect, some function being done, of life done by 90+% of the adult U.S. population, dependent on computers. Okay, so no one now, because you're going to need to know it later. What's something that everybody does that uses a computer? 90% of the adult population. I cut you a lot of slack in the 90% department. One more time? Grade. Just pick something every day that most people use that uses a computer. Okay, let me give him a hint. Let's say 90% of the people use a phone. I think that's probably true. There's a computer in that phone. And that one actually does 90% of it, of adults. Right? We'll call an adult 18+. Because that's the age of voting. We'll call that, and the age of draft. We'll call that you're an adult. We can send you off to war and we can let you vote. We'll call you an adult. Here's a fun fact. When I was in college in North Carolina, remember North Carolina, the drinking age was 18. When I got to college, I was still 17, so I had to wait a couple of months. But then, me being me, took the rest of the semester. I would end up drinking at the end of every semester. While everybody else was studying for exams, I went out and drank. Because studying for exams never does any good for me. Whatever I've learned through the semester is all that I know. Studying does no good for me. Okay, next person. What's something else 90+% of the population does? Type? On a typewriter? Typewriters don't have computers in them. Open a web browser. Now, do we think 90% of the adult population does that? That's going to be pretty close, right? There's a bunch of old people like me and older who don't. My mother, who was 80, I have to calculate, she's probably 83 now. She does it. She's a whiz bang at it. So that's a good one. Next, what's another thing 90+% of the population do? Sending emails. That one is becoming less and less true because what does your generation do more than emails? Instant messaging. In fact, when I tell my daughters to send me an email, they don't say anything, they don't even make any funny gestures, but I know they're thinking it. Okay, I'll try and remember how to send an email. Now their teachers are very good at that. So 90% calling you guys, I'm not sure that's true. But you probably have to use some emails. But another thing. Look at new stuff on the computer, yeah? Look at new stuff on a TV. Do you think your TV is likely to have a computer in it? Who thinks it is? Who thinks TV has a computer? Yes, they do. At a minimum, you have to have an HDMI to RGB converter. What's the point of, next person, what do you think the point of this question is?
Thinking.
Thinking, that's exactly the point of this question. Go through life and look at things and wonder. Think about how they work. Don't believe in magic. There is no magic. Look at things and think how they work. One of the reasons to think how they work in the computer realm is to think how a hacker might subvert the thing and drive you off a cliff. Of course, there are instances where Google will drive you off a cliff with no hacker. They fixed most of those things. There are instances when Tesla will drive you into the side of an 18-wheeler with a sky painted on the side. That happened in Atlanta 2-3 years ago, but it happened. Driving, no one said driving, right? Almost, well, excuse me, nobody said driving in this. A number of people said driving in the answers on the test.
Is a calculator a computer?
A calculator is a computer, but it depends on what you're doing. If someone said simple math, you're doing that in your head, or at least you should be. Driving, almost all cars use them. Not all cars, right? There are cars, older cars on the road that don't have any computers in them. Okay, who does not have their test? Please come get it. 22. In one of the, hang on, I'll ask more specific questions in just a second. In one of the labs where you had to print like negative or positive or large and negative and something else, the something else someone else wrote was the exam will be all multiple choice. I found that funny when I graded that, knowing what the exam actually had on it. Okay. Point. Okay, let me hang on. Complete the following code to 1. Ask the user for a negative integer. Let's just do that part. Oh, class rules. People keep sending me emails asking me about assignments and labs and things. Use lab time for that, because I just ignore the email. There are no exceptions, right? The reason there are no exceptions, if I make an exception for like one person, I have disadvantaged the other 60x of you, okay? That's why I don't make exceptions. It's not because I'm being pejorative to you, it's that I'm being fair to the other people who did it right. Okay, void main. Ask the user for a negative integer. How would you do that? Ask the user for a negative integer. What would you write?
Oh, well, to ask the user for a negative integer, first I'd call printf, and I'd give it an argument, give me a negative integer, semicolon, and then I'd call scanf, and then I'd do %d, and the other argument would be, I totally forgot. Before that, you got to do int number. Well, it doesn't really matter too much. There. Then for the second argument, you put ampersand x. Quote, yeah.
Okay. Any questions? A lot of people left off that. Okay. Number 2, print the first 5 negative numbers in descending order. Let's just do that part.
Okay, so first I add a printf function that just prints that number we just got from the user. So I did.
And then what would you do?
And then I use a loop, a for loop, where I initialize a variable I did in this case.
Initialize it too?
And I set it to 0. And then I did, as long as I is less than, or the condition would be I less than 4. It's either 4 or 5. But I'm going to assume 5.
It should be 5, because it said 5 of them. Less than 5 means 0 to 4, 0, 1, 2, 3, 4, which gets you 5.
And then I did an incrementation of just I++. And then the little bracket thing. I took x, I did set x equal to x minus 1.
Okay, this is why you need to print that up here.
Yeah.
So, okay, we'll come back to why that was incorrect, but so let's just say you said %d comma x. Okay. So you said x is equal to x minus 1,
Yeah.
decrement x.
And then underneath that, put printf %d, comma x. That should get you the little list of numbers.
Next person, will that work? You have a 50-50 chance.
Yes.
No. Next person, why will it not work? What do you think might be wrong? How many printfs are going to be executed? Here's one printf. How many times will this printf be executed? 0 through 4. 0 through 4 is how many times? So 5 plus 1 is 6, and we're only supposed to print 5 numbers, so therefore we know this won't work.
Could you change the I less than 5 to I less than 4?
That would in fact work. Why?
Because now we're not including the first printf that I had. So now that adds up to 5 and not 6.
And you're decrementing x before this printf.
Yeah.
So, what's a simpler way to do this same loop? Consider all of this as a unit. What's a simpler way to do it? What's it? Yes, I'm asking you to think on it because you may or may, there's multiple ways to do this. You may or may not have done it this way. Changing this to I minus I less than 4 would work, right? Well, what's a simpler way to do the same thing? Okay, go ahead. Yes, no, you, yes. Yes. Well, go ahead. What's the simpler way?
So on my declaration for x, I added a count feature onto it, and so I just set the for loop up. So
We'll come back to that one. What's the simpler way still using I going from 0 to some number? Go ahead.
You could decrement instead of increment. Wait, oh, never mind.
That's kind of what she's talking about, which we'll get to. Go ahead.
I just put the decrement after the print statement, so that way it would print 5 times, and then it would decrement after it printed.
That's a simpler way to do that. Eliminate this line entirely. That way you're doing things in the right order. What you did, if you did that, oh, you said less than 5.
Yeah.
So that was incorrect. But the rest, if you change it to less than 4, it will work. Okay, everybody understand why this one works so far? Okay. We're going to come back to the average in a minute. But let's do this yet another way. Like she was, like I hope she was talking about. Anybody need their exam? Did you email this to me?
Yes.
Okay. The for loop. How are you talking about doing that for loop?
so when I declared my integer x, I did comma count before the semicolon, and then instead of initializing it with I for the for loop, I did for count is equal to 0, count is less than 5, and then increasing the count each time. And then when I did the printf, I have
Okay, just tell me what the for loop says. We'll add the rest later.
count is equal to 0,
Go ahead.
and count is less than 5.
That's the same thing he did, but just a different name. Okay, who else did this differently?
So, I created a new, wait, hold on. Yeah, so, for instead of in count, I guess in count would work too, but I created an integer count. And then I had, for the actual x itself, instead of the, some kind of count for x, x is less, or no, sorry, I set count equal to x first, I think. Right, and then I did x minus, sorry, x is less, or x is greater than, sorry, x is greater than, this is for real this time, x is greater than count minus 5. And then the colon, semicolon, sorry. And then x equals x minus 1, semicolon. Or I guess x, is x minus minus the thing?
Yeah,
I guess that would work too.
same thing.
And then
X minus minus is the same thing as x is equal to x minus 1.
I put a semicolon at the end of my for loop for that last. Okay. And then I put,
That would be, should be finding the file, by the way, because it's not easy. Anyway,
um,
okay, so let's pause here.
Okay.
Let's look at what this will do. He's decrementing, he's setting a variable count equal to x. And you said x is equal to x minus 1 here?
Or
Okay. So what did you put inside the loop?
I put print f, and then open parentheses, %i, in quotations, comma, x. And then I put, I called it something else. Well, I put, actually, I did the, I created another variable.
Don't worry about the summing and the averaging right now. We'll come
Okay.
back to that. Okay.
Then
Hang
I
on.
did,
Next person on the back row. Who's next on the back row, on the next to back row? Did you answer a question?
No.
Okay, so is you. Will that work?
No.
Why not? Okay, so this gets to a good point. Like a computer, you have to think like a computer. How do you think like a computer? You have two variables here, count and x, right? So let's just see what happens. Let's suppose we took the example input, -5, okay? So, x starts at -5. Let's say output. So x starts at -5, count gets assigned -5 as the initialization statement of the loop. So then the question is, while x is greater than count -5. Count -5 is what? Count is what? -5 minus 5 is what? -10. So -5 greater than -10, is that true or false? It is true. So that means we enter the loop. We then say printf, whatever x contains, which happens to be -5. Okay, so we have some output. We go back up to the loop. X is equal to x minus 1, so what does x become? -6. What does count? -5. Count has not changed. So, x is -6. -6 is greater than -10? True. -6 is greater than -10. That's why this is part of the exercise. You have to think it through. You have to think like a computer. You have to be rigorous and exacting. Welcome to computing. So yes, -6 is greater than -10. So you execute the loop again. You do another printout. And you're going to print out, what are we printing out? X? Yes, x became -6, so you print out -6. Next person. I wouldn't let him have all the fun. Okay, so the next time through the loop, x is equal to x minus 1. So what does x become? -7. So you see the funny circles that are hard to read? It looks like they were done by a person in a cast. They were. My wife is in a cast. She does the first set of grading, and then I come through and regrade what she has graded and put the points in, or scratch out the grading mark or whatever. She only grades the multiple choice and the true false. Okay, what does count? -5 still. So, -7 is greater than -10? True. So you go to the loop, you output x, gets you -7. And so forth and so on until, same person, so x becomes -10. -10 greater than -10? No, so the loop stops. So if we achieved in writing out what we were supposed to, which I showed you on an example output, we've written out -5, -6, -7, -8, -9. And because I put a comma right there, we'll also have a comma behind each of those. Okay? So who gave me this loop? So your loop works. Well done. Why do you think I'm spending so much time on this? Is there a chance that you may have more things exactly like this in the future? Probably a good chance. Not just in this class, for the rest of your career if your career is computers. Okay. Next person. Howard, question?
I was just asking, you said that we were gonna get to whatever that is. Was there a specific name for that kind of loop, or is it still just a for loop?
It's just a for loop. This is the point. It's not just for moving things by one. And it's not just for, adding to the counter. The for loop can be used in multiple ways. Now this way, this is fine, right? This is simple, straightforward. You have to think a little bit harder to get to this one, right? This is a little more simple and straightforward, but it involves one additional calculation that either this one or this one is the additional calculation, this one is the additional calculation. So when you're doing 5, it won't matter. When you're doing 1,000,000, it might matter. Okay? But these days, for code readability and simplicity, I probably would have picked this one. Right? Actually, I know what I picked. I did it through 3 different ways. I did it that way first. Then I did it this way, and I did something else on my exam. Sir?
A question is, for the loop on the right, if you just put x minus I instead, would that have worked with printf? Like in parentheses x minus I.
Oh, instead of doing this,
Yeah.
getting rid of this and saying x minus I, that would work too, yes. And some people did that.
Do you have to put that in parentheses, or would the compiler be okay with it without that?
You just put the minus I here,
Mm-hmm.
and eliminated this, that'd be
Yeah.
fine.
Okay.
Because it's going to take whatever expression is here to put in that placeholder.
So you could put a method there too?
You can put anything that returns a value.
Okay.
A method call, for instance, that returns an int, or it has to return an int because this is the yeah. Next person. Hold on. Next person. Who was the last person? You were the last person. Next person. The average part. How would you do the average part?
Oh, I messed up.
Okay. Now how would you do the average part?
The outputs together.
How do you do an average of numbers? If you have 3 numbers, how do you get the average of those numbers? Any
Add
3
them
numbers.
together and divide by 3.
Add them and divide by 3. So you have 5 numbers, you add them together and you divide by 5. Basic math. So, next person, how would you do it?
How would I do it?
The average part.
I would take the same approach by dividing the integers by the amount of integers there are.
How would you do it in the code?
In the code, I would probably set average equal to,
Okay, so we're going to declare a variable called average. And what should you do when you declare that variable, though you're going to be adding things to it?
oh, I would set it equal to,
If you set it to start with?
So we set it to, just int,
Set it to 0, because otherwise it has garbage in it.
oh.
Just declare it and set it to 0. Okay, next person. What's the next piece of code you would write to increment, not increment, to add to the average each number you're doing?
I actually did it differently. When I was looking at the problem, I noticed that because we're always going to have 5 variables incrementing, I could just take the final one, which would be the last increment minus 1, and then add 3, and that will always be the average of them. So I
Suppose you don't know
alternated-
how many numbers there are.
Yeah. It just, that only works for this case, so that was a question. But otherwise,
That's a key answer. It only works for this case, right? If you're doing programming out in the real world or in here or anything like that, if you think to yourself, this only works for this case, you're doing the wrong thing. Right? Now, if you guys did that, because the problem was stated the way it was stated, I gave you credit, because your code was correct. So I couldn't in all legitimacy mark your code wrong if you did that. So some people said x minus 2, right? And they were correct. That would be the correct answer because I did say 5. So the next time I give this exam, and this is modified from the previous one, I might have simplified it more than I should have. It'll be modified so that some of the shortcuts you guys did, when I say you guys, I mean you guys in the world of C classes do, right? So that the shortcut won't be available. But anyway, so let's pretend like you didn't take the shortcut.
yeah. So final increment would be x, would be initial minus 5, so I would take, doing the for loop that way too complicated.
Because we change this to the x minus I variant, you say whatever the number is that you're on. So you've added all 5 numbers in.
Oh, you just keep it within the for loop.
Right. Because you already have a for loop to walk through the numbers. Next person. So now, so what's the next thing you would do? So we've output the numbers. Now we have to output average equal whatever the average is. So what's the next thing you do?
You do average equals average divided by 5.
Will that work? Sorry. Will it work if I have the slash going in the right direction?
Yeah.
Why? What is this equivalent to say?
That the average is equal to the average divided by 5.
That's correct. So that's valid syntax. You usually see it with plus equals and minus equals, but it'll work for any arithmetic operator, including modulus, percent. Okay, so we've set average slash equal 5. So we divided the total we acquired here by 5. Now what? And that's 22. So any general questions on 22? For your specific 22s that you may want to ask me questions about, wait till the lab period. But any conceptual questions on 22? $10.26. How many weeks is that from tonight? 2 weeks. Easy question. And for an exam 3 is? So we'll cover material for exam 3 tonight, next week, and then next week we will review for exam 3, and then 2 weeks from tonight, we will take exam 3. Just like we've done all the other exams. And yes, they do get harder each exam, because you're building on top of more material. You get questions re-asked, not re-asked, asked in a different way. Questions you have to understand to answer the more specific question. So do your implicit homework is ahead of that. We already talked about think like a computer. That's what you have to do. You have to execute your program as the computer would execute it. In your head, or on scratch paper, whatever. Okay. So let's talk about pointers and scope. What are the names of these two variables? Okay, x is one of them. What's the name of the other variable? It is just z. Even though z is a pointer type variable, the name of the variable is just z. This is important to know. I don't know what made me think someone didn't completely understand this, but I have a note to make sure we go over it. So it had to be a reason for that note. But we've already gone over it and somebody still didn't get it. The fact that this is a pointer and the asterisk is written closer to the z, there's a reason for that. I went over it with enums, right? You can make an enum pointer. It's still part of the type. It's an integer pointer named z. Okay, that's what that really means. So, hopefully you now see that you have understood that you have to understand pointers and how pointers work. That pointers are references. First of all, let me compliment most of you for writing ampersand much better than I do. I was impressed. I can write it if I work at it. Like a backwards A. Anyway, never mind. This is why I don't try. I just write ampersand like that. Okay.
It's a 2 with a line through it. There we go.
Okay. Yeah, okay. You may have solved my many-year problem. Okay. Next, seriously. That looked pretty close. Next person. What does the ampersand operator do? What is it? Okay. So it creates a reference to a variable. So let's suppose my variable is v. So ampersand v creates a reference to v. So what is the name of the ampersand operator? The name, okay. So you have, what's the name of this operator? Addition. What's the name of this operator? Subtraction. What's the name of this operator? Reference. Just for completeness. While we're on it, what's the name of that operator? Fair enough. As you saw from some of your answers to the last programming problem, if I ask the question in such a way that you can answer it like an idiot but still correctly, you still get credit. Not like an idiot. Some of you just took the straightest path, from point A to point B, even if it was up a big hill rather than through the tunnel. Okay. Yes, it is multiplication. What is another name for the asterisk operator used in a different context? Okay. It's my fault for asking the question wrong. It's not his fault. And you know what? This is a good review, so it never hurts. It can be used in a pointer declaration. You're exactly correct. Okay. What's the third? Maybe there's a fourth possible use of an asterisk operator. What other operator could it be? Dereference. And I'm very serious. These were completely valid and correct answers. This was the one I was getting to. I wasn't asking the question. I was trying not to be specific. Star is the dereference operator. So what is the opposite of the addition? Let's move on to the next verse. What is the opposite of the addition operator? I can't hear you at all.
Subtraction.
Subtraction, right? That's the opposite of the addition operator. What's the opposite of the reference operator? Dereference, that's correct. So, the reference operator says, give me a pointer to that value, or a pointer to something. The dereference operator says, take the pointer and give me the something. That's what those operators do. Okay? So let's take a hard example. So if I wanted to make z point to x, what would I put over here? I'm declaring an integer pointer named z, and I want it to point to x. What do I put over here? You guys know you're going to have a job interview at some point, and someone's going to do exactly this, right? You do know that, I hope. We're going to do exactly what we're doing in this class. It's one of the reasons we do it, right? Not the main reason, but it's one of the reasons. So in other words, they're going to look at you and expect an answer, some answer. So, some answer. What do you think you put here? X? Think you put X there? Okay. Next person, do you think that's correct? Why?
X is already declared, so if you point z to x, it'll give you a value.
X has a value of 3. You're putting a value of 3 into this pointer. What do you think that means? What is a pointer? What does it point to? It points to a piece of memory. So you've just arbitrarily said point to memory address 3 by assigning the value of x to it. So it can't be that. Ampersand x. Why?
Because then it gives you the reference to x. So when you call the pointer, it'll give you whatever is at the reference of x. Or when you
Let's save off that last part. You're right about it, but let's just do this, right? Ampersand x says, give me a reference to x. Give me a reference, another way to think of that is, give me the memory address of whatever's to the right of it. That's what the ampersand operator does. It's the reference operator. You can think of it as, get me the memory address of. That's a kind of a long phrase. That's why they call it the reference operator. But this is what it is literally doing. Get me the memory address of. So suppose I declare another integer y. My wife says, why do you come home with your hands so dirty? Okay, so I want to put the value of x into y. What do I put over here? You could put x. Suppose I want to do it a different way using z. What would I put? Dereference, which is what? Asterisk z. That's correct. This is the other point he was getting to, but I wanted to pause. Okay? So dereference can be thought of as get the value at memory address of. That's why it's the opposite of reference. Learn all this, understand it deeply. Everything else in the class is about this. Not everything else. 2/3 requires you to know this deeply and understand it and be able to use it. You will have to read programs and write programs using it. Questions about pointers, reference operator, dereference operator? Okay. Value versus reference types. A value type is everything in C except for a pointer, which comes from using the reference operator or arrays. Everything else is a value type. Integers are value types. Floats, doubles, longs, they're all value types, which means they contain values. The things that are reference types in C are pointer variables, because they do not contain values. They contain memory addresses. Now, yes, the memory address is a value, but there's really a memory address, which is a reference to something. The other case is an array. An array, an unsubscripted array, is a pointer. It is a reference to memory. When you subscript it, so let's suppose you have int r, arr, pointer. Arr is treated as a pointer to the entire set of memory that starts at arr sub 0. But arr is a pointer. As soon as you subscript it, it becomes the value. Look up arrays as pointers. Read up on it. Read the stuff. How would I do pointer arithmetic? How would I do pointer arithmetic? So I say, has declared an integer array with 20 characters. What does PARR represent? It holds the memory address of the array ARR. Just using PARR, how would I get to the 13th index of the array ARR? No, without a subscript. And it would be 12 actually. But in other words, I could say int I is equal to PARR. That gets me to the 13th element. How else can I get to the 13th element? PARR plus, I'm sorry, what? I mean, I can just be 13. That's a pointer expression that is now pointing 13 integers in from PARR. You dereference it. Say, get me the value at memory address 13 down from the beginning of PARR. PARR plus 13. Remember, the compiler knows that it's an integer array, so you don't need to do the size of it. It'll add the times 4 for you. But I like the way you're thinking. You're thinking deeply into it. That's a good thing. Right? But the compiler knows that, and he'll add the times 4 for you. Plus 13 gets you a pointer at the 13th element of the array that PARR points to, which is ARR. And then you take that pointer, dereference it. Dereference means get me the value at memory address here. And that's going to be equal to, did I say 13? Hopefully I said 13. Oh, I said the 13th. So for this case, the 13th is actually at index 12. Because indexing starts at 0. But for the purposes of moving PARR, you got to move it all 13. And dereference it to get the value, and then you get the value out.
Why are you adding 13 instead of 12 though?
Because you have to move it, yeah, you have to move it 13 places.
But isn't it already pointing at 0? So if you move it one space, aren't you going to the second spot?
So if you say plus 0, you're at index 0. You say plus 1, you're at index, you're right. Sorry? He is correct. Thank you very much.
Would it be wrong if I just said in pointer p array equals array brackets 12 in the second line?
You can say all sorts of things. I want to make sure you understand this thing. Okay.
In the second line, why does ARR not have to be capitalized? Okay, so does it have to
It has to match this,
Okay, that's, okay.
because case matters
Right.
in names.
Do you even need pointer PAR? Because AR is already a pointer.
You need it for the point I'm trying to make, yes. In other words, this tells you explicitly that it's a pointer. That's why I'm putting this up here for you to learn.
If we did like ARR plus 12,
Don't give me what ifs. I'm trying to teach something.
I
okay?
write a new line int z equals ARR plus 12 would it reference ARR location?
Int z? No. Int z is an integer.
Would it
PARR
be equal
plus
to,
12
would
is
it
a
be
pointer
equal to,
expression.
if I did int z is equal to ARR plus 12, would it equal ARR's 13th slot?
No. It would equal some random memory address stuck in an integer variable.
If I had an asterisk in front of it, would that then?
I said no what ifs. You need to learn this. You need to learn this and understand this. Understand every bit of this. Is there another question back here? This is the last refresher on pointers, pointer arithmetic, arrays as pointers, so on and so forth. From now on, it will be assumed that you understand it deeply and correctly. Because you've had plenty of time to do your implicit homework to understand it. And it's also fine if you don't have the aptitude, right? Remember? That's the best style I can get. It's okay that I'm terrible at art and I will never be good at art. It's okay. I don't do art for a living. That's fine. It's okay. Except I now may be able to draw an ampersand better. I like it. Yeah.
Try having
All
the
right.
bottom
Thank
line,
you.
try having the bottom line point upwards.
Too bad you don't get extra credit for that. Okay, questions about pointers, pointers as arrays, pointer arithmetic? Scope. Know about value types versus reference types. Look that up. Make sure you understand that. That's pointers. Scope. We already talked about scope. I'll talk about it a little bit more because it matters for some of the programs and exercises, labs you're starting to write. Somebody asked me a question earlier that scope bears on. Scope really means what can be seen. So let's take a trivial little program. I've declared an integer named global. It has the name global is not significant, except I'm trying to illustrate something. Okay, this is my little program. First on that side on the second row. It just compiled. Yes, everybody look at it carefully, because you may be asked next. It'll take a minute to look at it, so go ahead. You have a 50-50 chance for will it compile, but you know what the next question will be, so will it compile?
No.
Why not? That's the next question.
You don't have the reference in the function.
One more time?
You don't pass the reference in the function, the main part.
Are you saying that I cannot call function here?
You don't pass the reference in the function.
No, it compiles like this. Function can be seen. That's a good point, though. This can see, a function can see anything global to it, right? A method called main can see anything global to it. This function is global to it. This function is one function. This function is another function. They're at the same level in the program. And this one is ahead of it. So it can definitely see function. So in the printf statement, can this see local?
Is because in the function you use void, so that doesn't return. I don't know.
So this integer named local is only visible within this function because it is declared within this function. Outside of this function named function, the variable local cannot be seen. So the compiler will not be able to see it because it's inside this function. However, this variable named global, which is not inside this function or any function, can be seen by all functions that occur after its declaration. Okay, this is what is meant by scope. So the scope of the variable named local is simply within the function named function. That is the scope of the variable local. Outside function, it cannot be seen by anybody. And the compiler will give you a compile error if you try to reference it. So this would give you a compile error that says, no such variable local, or something like that. But this print statement is within this function, so anything within this function, after the declaration of local, can see local, because local is within the scope of the function. So it's perfectly valid to use local in the function. Now this variable global is outside of this function, but global to it, higher than it, so it's valid to use it too, because it can see it. So that is what scope means. What can be seen? Part of your implicit homework, go read all about scope and what it means and what its practical effects are. Because in some of your programs that may be getting compile errors, you have scope issues like that. I don't know that because I haven't looked at them closely. But I bet some of those compile issues are scope issues, that you're trying to reference something that logically cannot be seen from where you're trying to reference it at. So you're going to need to know this and understand this in the programs, particularly in program 3, where you have to use methods and pass references to variables. Next person, what is a reference to a variable? What's another name for it? A reference to a variable. So over here, somewhere, I erased it. Reference to x, I've assigned it to z. What is z? What type is z? What's that?
Integer?
What's that?
Yeah, the pointer?
So z is an integer pointer. I've assigned the reference to x to
Z. Yeah.
to z, which is what?
Which is.
Which is an integer pointer.
Yeah.
Therefore, what is a reference to a variable?
A pointer?
A pointer. You will not learn it in this class. I I can tell you, but I can tell you don't understand it. On the UU, I mean the global U, and not all of the global U, but you have to do the work. You have to go read it and understand it, and try things, play with programs, make sure you understand it. Next person, what is the only way to learn how to program?
Practice?
To practice programming, that's right. No other way. I mean, you can read all sorts of stuff, which is good preparatory work, but then until you practice programming, it's not going to mean that much to you. Okay, that is scope. Please go read about scope. Okay, function calls. We've talked about function calls. This is a function call. For it to be a function call, it has to be the name of the function followed by parentheses with the parameter list inside. We've talked about signatures of functions and methods. Functions and methods are the same thing. We've talked about signatures. We've also talked about how you can have a void return type for a function. Now let's suppose you don't have a void return type. And for our purposes, let's make this simple function that just returns a value of 3. How do I get that value? How do I get the value that my func returns into a variable? So I say I want to get it in integer z. How do I get the value of func into integer z?
Use a pointer.
No, not complicated. You just call the function. That is calling the function. This will return an expression of type int, because that's how my func is declared, is as an int. So it will return an integer expression. And then you can do anything you want to with that integer expression. You can assign it to a variable. You can use it in a calculation. You can actually say, because it'll return an expression, then you can multiply it times 2 and then assign it to the variable. Next person, suppose you just call my func like that without assigning, without doing anything with the return value. Is that valid? It is valid. Because the compiler says, okay, return something, it's going to throw it away. Now in this case, it makes calling my func pretty meaningless, but it's perfectly legal. That's really all there is to calling functions, except for parameters, which we'll talk about in a few minutes.
Can you only call functions in a main function?
No, functions, you can call other functions, as long as they have the scope to see them. Functions can call themselves. That's what we're going to talk about when we get to recursion. It can call itself multiple times. We're not going to do a lot on recursion. We'll do just a little bit to illustrate the point that a function can call itself, right? But when you get to, if you get to data structures, right, you'll use recursion a lot because it's a very handy mechanism for doing certain things in data structures. Okay, questions about any of this so far? All right, 10 minutes of break. Question up here? Go ahead.
What is there substitute after the whiteboard?
Just to illustrate that this returns an expression, and if I want to multiply what that expression returned by 2 is, I can. That's just an example, doesn't matter. I could have said plus 4, I could have said divided by 3, because it's just an example. The point being, my func returns an integer expression. Do with it as you will in your program. That's the point.
Why is there 3 after return instead of 0?
That's returning the value 3 as when you call my function, that will always return 3 as the integer value.
Also,
I could have put something more complicated there, as long as it's an integer function, an integer expression. I could have put 3 times 4 divided by 2, which would be 6, and it would return the value 6.
it's going to go to my function.
That's going to be the return value of the function named my function.
And then z is also gonna be equal to, or NC is also gonna be equal to.
Z gets assigned whatever the return value of my function times 2 is in that example.
Okay.
Okay, for the last subjects of the day, of the evening, we're going to talk about functions and recursion. So, this is a recursive function. The things to note about this recursive function is that it calls itself. That's what recursion is a method calling itself. This recursive function does exactly that. It returns the sum of integers up to the parameter. The parameter being n. Your homework between now and next week, copy all this down exactly, or take a picture of whatever your mechanism is. Put it into a program, make sure it runs and runs correctly, and understand every facet of it. There will be a test next week. Well, that's an exam.
Oh.
We'll call this a pop quiz or something, or a test, what do you want to call it?
Do you have a comment on the format of the exam or test?
Nope, never. Have I ever commented on the format or whatever of the test or exam? Never. Know the material, you'll be fine. Don't know the material, you won't be fine. All exams are that simple. Or some percentage of the material. This is a pretty contained set of material. It uses a function. It obviously has a main function to call the function we created. If you want to be more creative about how you get the number, knock yourself out. But I'm not going to grade the work you do. There's going to be a test about information regarding this. This is a recursive method. Okay?
What do you have written in the print statement?
Right here,
Yeah.
that's a 3. But you can put any number there. It'll return you the correct value. So if you put 5, it's going to add 1, 2, 3, 4, 5. It'll give you that number back.
I mean, it says %d, and then is that /n?
Oh, sorry. Percent, quote, %d \n. That's just the format. Okay, questions? Okay, that's it for tonight.